Okay, today we're going to talk about implicit differentiation. Okay, so before we've only been deriving equations that had a y equals and then everything with x. So like this is what we've been doing. So y and then everything with that's x related on one side. So we have actually been doing this all along, we just haven't been writing it. So what differentiation means is we're going to differentiate the variable with respect to x. Okay? Now, what if I differentiate this variable with respect to x? I differentiate the y with respect to x. Okay? Now here, this would be 12x squared, and I was differentiating the variable x with respect to x. And then here, this is 16x, and when I did this, I differentiated the variable x with respect to x. Whatever variable I have, I was differentiating it with respect to x. So, do you see what this is? This is just 1, so I don't really need it. And then we've just been writing the differentiation of y with respect to x as y prime. So that's what we're doing. Okay, we've been doing it the whole time. We just haven't been obviously writing it in there. Okay, so I'm going to do this the long way for first time, and then I'll just do the shortcut the second time. Okay, so here we go. 3x squared, right, with the rules, and then I differentiated it with respect to x. Plus, this would be 12y cubed, and I differentiated that variable with respect to x, plus 3y squared, and I differentiated that variable with respect to x, and then the derivative of a constant is just 0. Okay, so I'm going to see now that I'm going to get this to cancel. Okay, I'm going to keep everything together that has a dy or dx in it and move everything else to the other side. So negative 3x when I move that term over. Now I'm going to factor out the dy over dx. 12y cubed plus 3y squared. And then to isolate it, I now would have to divide. So the differentiation of y with respect to x equals negative 3x squared over 12y cubed plus 3y squared. Okay, so I'm going to show you the shortcut here. So with respect to x, you don't even need to write anything extra, so just 3x squared. And then for here, we're going to go plus 12y cubed, and then just write a y prime every time we do a differentiation with y, plus 3y squared y prime equals 0, and then it would just be the same strategy. So y prime, I'm going to factor out, and I've moved the other things. Okay, same idea. So this and this, they are the same thing. Okay, so here we go. Differentiate 2x. This is 3y squared, and now it's got a y prime on it. Okay, now we've run into something different. This, I'm going to have to activate the product law. Okay, so I'm going to have this chunked as my first term and this is my second. Okay, so think about the product law. Ready? Derive the first, keep the second. There's no y prime on that, right? Because I didn't differentiate anything with respect to y right now. Plus, keep the first, derive the second, and now I need a y prime because I derived something with y equals 0. Okay, so this and this are going to have y primes in them. So 3y squared y prime. I'm going to put those coefficients together. Okay, plus 8x squared y prime. You see that? 8x squared y prime. I'm going to move this, factor out. So y prime equals negative 2x minus 8x y squared divided by okay, so just be careful when you're activating the product law that here you'll notice that I just had a y squared because I only derived the first thing, which was x. And then here I had to do y prime because now in the second part of the product law I derived a y.